So today we'll start with one more last topic, that is PLDs and memories. Okay, PLDs and memories will start. Okay, is it fine? PLDs and memories. Okay, yeah. One second. PLDs and memories. Okay, PLDs and memories. Okay, so PLDs and memories. If you take the PLDs, so first we'll see the programmable logic devices. Programmable logic devices. Okay, so logic devices, PLDs. Okay, devices, these are nothing but PLDs. Okay, so programmable logic devices. So the process of entering the information in these devices is known as programming. Okay, so normally there is a software programming, no. So this is nothing but one type of hardware programming. Okay, so the process of entering the information. Okay, whatever the uh, information into these devices, uh, so is called programming. Okay, programming. So programming is what, software programming. Okay, so uh, programming means programming means hardware programming, not software programming. So this is software programming. Okay, so sorry, hardware programming. Yeah, programming means what? Hardware programming. Okay, hardware programming. So you have a group of that is AND gates and OR gates. We call as AND array of array of AND gates. Okay, AND gates and array of array of OR gates. Okay, OR gates. Array of AND gates and array of OR gates. Okay, so these are of three types. One is uh, programmable read-only memory. So programmable read-only memory. Read-only memory. Okay, programmable read-only memory. So this we call as PROM, programmable read-only memory. And the next one is programmable array logic. Programmable array logic. Array logic. So this we call as PAL. And next is programmable logic array. Programmable logic array. Logic array. So this we call as PL. Okay, PL. So we'll see each and everything in detail. First we'll see the uh, what we so this is a PROM. Okay, first we'll see the PROM. Okay, programmable read only memory. Okay, programmable read only memory. Read only memory. Okay, read only memory. Yeah, memory. So this programmable read only memory, if you take, you have so whatever the ROM is there, ROM is non-volatile, no? Non-volatile. Non-volatile means what? When the power is shut down, so the data will be permanently stored in the binary information will be permanently stored. Okay, whatever the binary information that will be permanently stored. Okay, permanently information stores permanently. Okay, suppose in the uh, laptops also you are using nowadays. Previously in olden days you used hard disk. Nowadays you are using HDD, solid state devices. Okay, SSD. We are using SSD, no, SSD. So those are nothing but one type of ROM only. So whatever the files and whatever the OS related operating systems, that will be stored in ROM only. Okay, so how we can program? So that means we can program electrically. Okay, program, how we are you programming, so we will program electrically, ones, or one type of programming. Your pen drive is there that we call as flash drive. No, flash drive. Flash drive. You can like erase the data at a time, some block of data like that. So now we are discussing PROM only. So what is this PROM? PROM means you have fixed fixed and array, fixed and array, and programmable or array. Okay, programmable or array. Okay, or array. So like if you see, so by using this PROM, we can generate all the minterms. We can generate the minterms. Okay, so minterm. So here if you see, you have fixed. This is fixed and array, fixed and array, and so you have n inputs, and next programmable or array. Okay, this is programmable or array, programmable or array, programmable or array. You have m outputs, m outputs. Okay, so what is the fixed and array you are using? Tell me. Can anyone, can you say what is the fixed and array you are using? You are using one combinational circuit only. You already studied one combinational circuit. With one combinational circuit, we can generate all the minterms. All the minterms. Yes, yes, decoder. We are using decoder. Yeah. You got an idea about the decoder? Okay, decoder. By using decoder, we can generate all the minterms. Okay, so that means for fixed and array, you are using what, decoder. Okay, you are using decoder. Okay, so you are using decoder circuit. Okay, decoder we are using. Okay, so suppose example we will take. Okay, example. So let us take one example. uh, so one example, suppose he given a of x y z equal to m of summation of m of 5 6 7, and b of x y z, that is equal to summation of m of uh, 3 5 6 7. Okay, so here given, so how many functions they given? Two functions, no? Two functions, and this is in which form? SOP, no? Sum of products, sum of products. Okay, SOP, and so it require, so three inputs are there. Three inputs are there. It require which decoder? 3 to 8 decoder, no? 3 to 8 decoder. So how to draw this? First you draw the 3 to 8 decoder. Okay, so this is 3 to 8 decoder. 3 to 8 decoder. So you take the three inputs. What are the inputs? These are x, y, z, and each decoder will produce one minterm. Okay. So this is M0, M1, M2, M3, M4, M5, M6, and M7. Okay. So this is so these lines you will connect like this. Okay. and this is M7. Okay, and here, so this is one OR gate, fixed AND gate and programmable OR gate. No, okay. So whatever the minterms are there, just you program. So what are the minterms he given? M5, M6, and M7. Okay, and next here you have this is B function. So this is B function, and what are the minterms? Yeah, M3, M5, M6, and M7. So like this, you need to design the Pro. Did you understood? Okay. Yeah. So next we'll see the programmable array logic. Programmable array logic. Programmable array logic, that is PAL. Programmable array logic, that is PAL. It consists of PAL. Okay. So this is nothing but we call as PAL. Okay. So PAL have programmable AND array, programmable AND array, and fixed OR array. Fixed OR array. Okay, fixed OR array. Okay, so we can generate. That means only required product terms in the Boolean expression. Okay, so if you draw the logic block diagram, so you have programmable AND array, programmable AND array. So you have n inputs. Okay, n inputs and fixed OR array. Fixed OR array. Fixed OR array. Okay, fixed OR array. And you have m outputs. Let us take m outputs. Okay, so how to design this? Suppose let us take three inputs are there. Okay, three inputs, how we are doing? So let us take, this is a. So a is coming like this, and a bar. Okay, and next this one is b, and next b bar. Okay, and c, this is c and c bar. Okay, and some like these are some uh, array of AND gates, like some array of AND gates. Suppose three AND gates are there like this. Okay, one second. Hello. సరే క్లాస్ లో ఉన్నా okay. So see here, so this will be like programmable AND array. This is programmable. Okay, this is programmable. So all are programmable. And suppose if you take the OR array, so this is my OR array, fixed OR array. So fixed OR array means how it will be there. So like this it will be there. Fixed OR. Point will be fixed. Okay. Did you understood? Okay. Okay. Yeah. So here if you see, suppose one example we'll take. Okay. We'll design implement this function by using PAL. Okay. Let us take xy plus xz dash and b equal to x y dash plus yz dash. Okay. So here how to design this? First, you need to draw this. What is this? X. What are the inputs? X, Y, Z. No. X, Y, Z. So here like this you are giving. So this is X and this is X bar. Okay. And next this is Y, and next it is giving, this is Y bar. and next Z, and this one is Z bar. Okay. So programmable AND array. So programmable AND array means, let us take this is an AND gate, and you are giving like this. So X Y. So this is X and this is Y. Okay. So what is this? This is nothing but X Y. Okay. And next X Z dash. This is X Z dash or X Z Z dash. Okay. X Z dash means what? This is X and Z bar or Z bar Z dash, both are same only. Okay. X Z dash. Okay. And next X Y dash. X Y dash. How we are getting? This is X Y dash. Okay. X Y dash means this is programmable. X and Y dash. Okay. And just this you expand this you expand. Y y z dash, yeah, y z dash. Y z dash means this is programmable. So this is y and this is z dash. Okay. Again fixed r array. Fixed r array means what? So this is or gate. Okay. Or gate, you are getting a. So x y dash and x z dash. Fixed or array. With the dots you need to implement. Fixed or array. So this is B, X Y dash, X Z dash, Y Z dash, yeah, Y Z dash. Is it fine? Okay, this is mm, 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 mm. Yeah, yeah. So AND gate is programmable. That means programmable means what? Just like a fusing only. In your household, some fuses are there, no? Getting the current like this fuse is there, no? So like this one wire is there, no? Like that only we are programming. Okay, yeah. So one second, I will add the slide. Yeah. Next, next. What is the next one? Programmable. Second. Draw. Yeah. It's going. Yeah. Programmable. Programmable logic array. Programmable logic array. So programmable logic array (PLA). So PLA, if you take, so both, so you have in this PLA both are both programmable array and array, programmable and array, and programmable or array. Both are programmable. Okay. So if you see the block diagram, so both are programmable. So you have, let us take n inputs, and you have m outputs, and this is connected like this. Programmable and array, and programmable. Okay. Oh, okay. Okay. Here you have so suppose this will be programmed. So like this, these are connected to suppose one AND gate. Okay. So one AND gate and the inputs are connected to one AND gate. Okay. AND gate and like this, these are programmable. Both are programmable. OR gate is also programmed. Okay. So both are programmable. Okay. So we'll see one example with respect to PLA. PLA. So if you see the PLA, yeah, PLA. Let us take A equal to XY plus XZ dash Z bar. B equal to XY bar plus YZ plus XZ bar. Okay. So here you have X. This is X and it is connected with an inverter. This is nothing but X bar. Okay. X bar. And next Y. Y is connected with an inverter and here you are getting Y bar. Okay. And Z. Z is connected with an inverter. You are getting Z bar. Okay. Z bar. So here one is AND gate. Okay. So one AND gate. Here XZ bars are common. No, I can reuse with one term. No, X Y X Y. This is X Y. And next, what is the next term? Tell me the next term. XZ bar. Yeah, X Z bar. Z bar. Yeah, XZ bar. And next YZ. XY bar. I'm writing. XY bar. This is XY bar. Okay. And next XZ bar. Yeah. X. This is XZ bar. Z bar. Okay. And this is here you are getting OR array. Here you are getting OR array. This is OR array. So here this is connected to what is this first function xy plus this is xy, no, this is x z bar and x y bar and x yz. This is yz, yeah. uh, uh, so this is a, yeah, this is a. And next this one is b, yeah. Tell me. X x y bar, yeah, x y bar and next yz x z bar. Is it fine? Do you understood? Okay. Yeah. This is about the like RAM, this PLA, PROM, PAL, and PL. Shall I move forward? Mm. We are reusing, no. This one XZ bar is there, no. XZ bar we are reusing here and here. I'm considering means for XZ bar, no need to draw two times. So I can draw one time. I can reuse this XZ bar in A as well as B. Is it fine? YZ, yeah, yeah. Mm. YZ. Okay, 1 second. This is YZ. This is YZ. Okay, okay. So this is AND gate. We need to mark Y and Z. Yeah, YZ. Yeah, yes. Now it is okay, no? Hmm. 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 Yes. Okay. So next, random access memory. Okay. Next is random access memory. We call as RAM. Okay, RAM is a random access memory. Okay, so what is this RAM? Okay, RAM memory is used for faster executed in processor. Okay, so with that means whatever the with respect to processor for faster executing, you are using this RAM. Okay, faster execution. Okay, for faster execution, you are using in a processor. Okay, in a processor we are using. Okay, suppose your mobile is there. Your mobile is suppose 16 GB of RAM and uh, how much of like 512 GB of internal memory we call now. So this is nothing but previously we already seen now. It is one type of flash memory and this is nothing but we call as RAM. Okay. So RAM is non-volatile. RAM is volatile in nature. Okay. What is volatile in nature? When the power is cut down, whatever the data is there, that will be erased. Okay, so that is nothing but volatile. Okay, uh, so RAM, where we are using RAM is used to store the data, temporarily, temporarily, which will be processed by currently processed by the CPU. Whatever the data currently processed by the CPU, that will be stored in the RAM. Is it fine? Currently processed by the CPU. Okay. Uh, so here there are two types of RAMs are available. So there are two types are there. So those are one is SRAM. SRAM means what? Static RAM. Static RAM. And next one is dynamic RAM. DRAM. DRAM. DRAM means dynamic RAM. Dynamic RAM. Okay. First we'll see about the static RAM. Okay. Is it fine? Okay. So first we'll see the SRAM memory cell. So SRAM memory cell. If you see the SRAM memory cell, it consists of like uh, so it consists of so this type of memory is nothing but volatile memory, and it consists of two inverters connected back to back. Two inverters connected back to back. Okay, we already seen like in the sequential circuits, we already developed a memory, no? Like two inverters connected in cascade, and this will be feedback, and we are taking this qn present state, and this one is nothing but qn bar. We already seen, no? Okay, so this is nothing but one type of latch. Okay, so suppose if you want to store like 0, here 0 will give, you are giving 1, here 1, and here you are getting 0. 0 will be stored like this. Okay, and is it fine? Okay, so again you are using two fast transistors. Fast transistor. Fast transistors are nothing but T1 and T2. Those are nothing but NMOS transistors. What are those? NMOS transistor. NMOS. NMOS transistor. NMOS means what? N channel MOSFET. Okay, N channel MOSFET. Do you have idea about MOSFET? Okay, NMOS is actually in the MOSFET. You have NMOS and PMOS. PMOS with what? P channel MOSFET. Okay, P channel MOSFET. Okay, so that means PMOS will be like this. So that means here, like the symbol for PMOS is this is like bubble will be there. This we call as PMOS. Okay, so the ideal case for PMOS, ideal case when input equal to 0, this will be off state. Input equal to 1 means this will be on state. Okay, similarly for PMOS, if input voltage equal to 0 means this will be on state, and input equal to 1 means this will be off state. Okay, so so here what happens means so we'll see. Yeah, so first I'm drawing the SRAM cell, SRAM cell, static RAM cell. So how it will be there means first you have two inverters connected back to back. Okay, two inverters connected back to back, and here you have two pass transistors, okay, so this is one pass transistor and this is one more pass transistor. Okay, so pass transistor is more normally this is which type of transistor? I told you, no, NMOS. So this is given to which line means word line. This is given to which line? This is nothing but we call as word line. Okay, word word line, and this one is nothing but we call as this is B, and this is B bar. This we call as bit line. Okay, so here there are two operations are there. Suppose if you have microprocessor and SRAM is there. Okay, so one is read operation. Read operation is nothing but what? SRAM can read the data from the microprocessor. No? Microprocessor can read the data from the SRAM. Okay, and the next to write operation. What is write operation? Write operation means microprocessor can write the data to the SRAM. Okay, first we will see the read operation. First read operation. Okay, so read operation means read operation if you take. So how the read operation will happen means first it will activate the word line. Processor will activate the word line. Means what? When word line becomes 1, this 2 transistor will be what? On. No? This 2 transistor will be on. Okay, this 2 transistors will be on, and after that whatever the bit value, let us take this is point A and point B. Okay, so suppose here like 1 is available. Okay, here 1 is there, and here you will get 0, here 0, and here 1. Okay, so that means at point A 1 is available, at point B what is available? 0 is available. No? So whatever the bit value is available at point A and point B, that will be transmitted to the bit line. Okay, so here what value is there in A bit point A? 1. 1 will be passed through the bit line, and here what will be available in point B? 0. So 0 will be available at B bar. Okay, and here so these are available. 1 is available at B, and 0 is available at B bar. Okay, so what happens? There is a sense or write circuit will be there. Sensor write circuit. Okay, so through this sensor write circuit, microprocessor can read the data. Did you understood the read operation? Here, there is a sensor write circuit is there. Through this sensor write circuit, that is one type of amplifier only. Through the sensor write amplifier, sensor write circuit, microprocessor can read 1 bit of data from this SRAM. Is it fine? Okay. So this is which operation? Read operation. Okay. Next I will tell you the write operation. Okay. First, next write operation. Write operation. So if you see the write operation, once again I am drawing this circuit. Okay, so you have two inverters connected back to back, connected back to back, okay, and two pass transistors are there, NMOS, yeah, one second, two NMOS connected pass transistors. Here this is bit line, and this is also a complement of bit line, that is B bar, okay, and these two transistor inputs are connected to which line? Word line. These two transistors are connected to word line, okay, this is nothing but word line, and these two are bit line, okay. So what happens, so here you have a microprocessor or a microprocessor, it can be microcontroller, or it can be DSP processor, or it can be FPGA also, okay. So any like we can call this as master, and this SRAM is nothing but we can call this as a slave, okay. So here this master microprocessor should write the data, no. So microprocessor inbuilt there will be a decoder, inbuilt there will be a decoder. So what is the operation of decoder? It will generate the address, okay. Suppose like suppose if you design in the Verilog, we are going to design 8 cross 8 RAM, normal RAM, okay. So 8 cross 8 RAM means what? Total how many locations are there? 8 locations are there, okay. So this is from 0 to 7, this is nothing but what? Depth of the location, depth, okay. And each location have how many bits? 8 bits, 8 bits, this is width, okay. So normally memory is defined in terms of what? Kilobytes. Your memory is kilobytes. Bytes means what? Each location is how many bits? One byte equal to how many bits? 8 bits, okay. And 4 bits equal to one nibble, okay, one nibble, and next 16 bits equal to one half word, 30 half word, 32 bits equal to one word, okay. So here memory is 1 kilobyte means how many locations are there? 2 power 10 locations are there. Your memory is 1 megabyte is there. Megabyte means you have 2 power 20 locations are there, and 1 gigabyte, 1 gigabyte means 2 power 30, and 1 terabyte means 2 power 40, like this your memory is there, okay. So here each and every location has a specific address, no? This is nothing but address, this is nothing but what? Address, okay. Suppose this is 8 cross 8 RAM means what is this address? 000, 001, 010. So before writing the data into the memory, first you need to identify the address, no? Okay, first it should identify the address where it should write the data, okay. That address is generated by what? Decoder circuit, okay. So when address is generated, it will activate the word line. So that means word line becomes what? One. So when word line becomes one, this becomes on, no? Both will be on, okay, both will be on. So processor want to write some one data, so through the bit line, okay. So this one data from the processor through the what we call through the sensor right circuit. Here you have sensor right circuit, it will place this one value into this bit line, and that one value will be coming over here, and here this is point A and point B. At point A, 1 will be occurred, and here point B, 0 will be occurred, and here 0, and here 1. So 1 will be stored like this, understood. Processor can write the data into the SRAM cell. You understood? Okay. So here so inverter how we are designing means by using CMOS circuits. CMOS, complementary metal oxide semiconductor. Okay. So inverter we already seen in the digital, no? This is nothing but A bar, 0 means 1 and 1 means 0. Okay. How we are designing means, suppose this is it is having the PMOS as pull up and NMOS as pull down. Okay, NMOS as pull down, and this is supply voltage VDD, and this is ground, and this is the output, and this is nothing but input. Okay, suppose if you are giving input equal to 0, input equal to 0. Okay, input equal to 0, this will be what? This will be on, this will be off. So how the circuit will be there? So this is the VDD. VDD. Ideal case means this is shorted, no? This is shorted. This is shorted, and next this will be open, and this is ground, and input is you are giving 0. You are getting output through VDD. So you are getting output as what? 1, no? Okay. Similarly, suppose if you take if you are giving input as let us take input as 1. Input as 1 means this will be off, this will be on. What happens? This will be off, this will be on means here you are getting. So tell me. So this is VDD, and this will be off means this will be this. This will be open, and this will be closed. So there is no connection between VDD and you are giving 1 means you are getting 0 1. Like this, inverter operation will be there. You understood? Okay. So here, how you connect 60 DRAM cell? So 60 DRAM with one inverter, how many transistors are required? 2, no? 2. Suppose two inverters connected like this, back to back, with in like feedback. How many transistors are required? 4. Okay. So here that same circuit, how I am connecting means, here this is word line. This is nothing but my word line, and this is bit line, and this is bit line bar, bit line, and bit line dash, BL dash. Okay, and here you have one pass transistor. Pass transistor. This is connected to word line. Let us take this is N2, 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 and here you have one PMOS transistor, and next one more NMOS transistor, and these both are connected like this, and here also one PMOS transistor and one NMOS transistor. NMOS transistor. One second. So this is NMOS transistor. These both are connected to ground. Both are connected to ground, and here this is PMOS transistor. So here you see. So that means this is inverter. Like this they are connected. No, like this they are connected. This input is connected to this output. No. So here if you see, this input is connected to this output, and similarly this output is connected to this input. Like this it is connected. Okay, and here one more pass transistor. This is it is connecting like this, and here one more pass transistor. This is NMOS transistor, and here it is connecting like this. So let us take this is P1 and P2, P2 N1 and N3. This is N3. This is N2 and N3 and N4. So total how many are required? 1, 2, 3, 4, 5, 6. So that's why we call as what? So this is 60 SRAM cell. What is this? 6T, 6T, 6 transistor SRAM memory cell. Is it fine? Okay. And coming to the DRAM, so coming to the DRAM, so DRAM consists of what? Means DRAM. DRAM means what? Dynamic RAM, no? Dynamic RAM. Okay. So whatever the binary data is there, binary data that will be stored. Okay, binary data that will be stored. So binary data is stored as a charged capacitor, as charged capacitor. Okay. So suppose data is not stored for long time. No, why? Because the capacitor loses its charge. No, data, whatever the data will be stored in the capacitor. Okay, data is not stored for long time. Okay, stored for long time. Why? Because capacitor will discharge. Suppose if you charge the capacitor, after some time what happens? Capacitor will discharge. No, okay, capacitor loses its charges. Okay, loses its charge. Okay, so for this DRAM require periodic refresh. DRAM require periodic require periodic refresh, periodic refreshing. Okay, periodic refreshing. So area of DRAM is small compared to area of DRAM is smaller. Why? Because you need only one pass transistor and uh, one capacitor. Okay. So types, if you see the types, you have 1T DRAM, 1T DRAM, and next you have 3T DRAM. Okay, 3T DRAM. So 1T DRAM will be like this. Suppose so here you have pass transistor. Okay, so there is a pass transistor. So this is pass transistor, and this is connected to which line? Means word line. Okay, word line, and here you have one capacitor, and this is a bit line. Okay, bit line. Suppose for read operation, suppose for read operation, microprocessor should read the data. Okay, so suppose in the capacitor is charging, means one will be available. So it will activate the word line. Word line becomes what? One. So what happens? This will be on. No? So this will be on means this will be available at the bit line. One will be available at the bit line. That one will be read by the processor. Okay. Through the here you also you have sensor write circuit. Through the sensor write circuit, it will sense this microprocessor. Okay. For write operation, what happens? Microprocessor will generate the address by using decoder. Okay, address by using decoder, and it will activate the word line. And so suppose it will want to write zero value, through the sensor write circuit, it will send this uh, so when it is activated the word line, this will be shorted, and it will send the zero value to this capacitor will discharge like this. If one is written into capacitor, capacitor will charge. If one zero is written into this capacitor, means capacitor will discharge like this. Okay. So this is about DRAM. Is it fine? Do you understood?